Okay, so we figured out the total dynamic head. Now we have to figure out the horsepower requirement. And so we have another data sheet that I'll send everyone, and it's entitled Pumping Plant for Water Control Data Sheet. And in this data sheet you can enter the cooperator, location, all the good information there, the purpose of the pump, in this case it's livestock water, so you just check right there. We're going to be using an electric submersible, so you check off right there. And then we have to figure out the pump horsepower right now. So on the data sheet we got, I would disregard the pumping head for now. We want to know the total amount of lift that we have to overcome, and the total lift is going to be 238.1 feet. 238.1 feet. Okay, so the total head is going to be the pumping head plus the lift. In this case, we're not having to overcome pressure head, so we're not going to put anything for the pumping head. In the case we were having to overcome the pressure in the pressure tank, let's say the pressure tank will kick in at 30 psi and turn off at, it turns off at 50 psi and turns on at 30. So that 30 psi would be what you use for the pressure head. In this case, we don't have a pressure tank. So the total dynamic head is going to be 238.1 feet, and the GPM right here is what you enter for the water inventory need, 5 GPM. The efficiency of the pumping plant is going to be 75%. And I have a rule of thumb for figuring out that. I think I printed it at the printer. Get that. No, that's not it. I have it somewhere here on my desk. Where the heck did I put it? Dang it. I know I printed it. Alright, well, for now, let's see, it's probably right here. There it is. Okay, sorry about that. So on the efficiency of a pump, it decreases as you go down in depth. So the rule of thumb that I'm going to give you all is when you have to overcome between 600 and 800 feet, use 70 to 75% of efficiency. When you have to overcome 800 to 1,000 feet, use 60 to 65% efficiency. And when you're using 1,000 feet and above, use 50 and 55%. Okay, so in this case, on this data sheet, we already have a horsepower. The equation here. So we're going to put horsepower is equal to GPM times total head over 3960 times efficiency. So let me write that down on the whiteboard here somewhere. I'll do it right in the middle of this. So HP equals GPM times total head divided by 3960 times efficiency. In this case, our numbers are going to be 5 GPM times total head, total dynamic head, 238 feet, and 3960 times 0.75, 75% efficiency. So let's crunch the numbers. 5 times 238.1 is that, divided by 3960 times 0.75, and we get a value of 0.4 horsepower. They don't make 0.4 horsepower pumps, so round it to 0.5 horsepower. So for planning purposes, this will help you guys in specifying the pump size you need for the contract. So there's your horsepower, that's what you need. Now we're going to go to the pump curve. I got one here. We need, on the pump curve, you got the total dynamic head always on the the left, and then the GPM on the right. So sorry to say it different. TDH on the y-axis, GPM on the x-axis. In this chart we have the different horsepowers for each engine or pump. Sorry, it doesn't go to a 0.5 horsepower pump. So in this case, we're just going to say we need 3 horsepower. We don't, but we're just going to say we do. We know that the total elevation difference that needs to overcome is 238. So on the side we have 100, 200, 300. 238 we're just going to say is almost in between. So we're going to go where 238 is here, and we're going to go across till we hit the GPM. And GPM is 10, 20, 30, 40. So 5 is right here. So where 5 and 238 hit is right at the 5 horsepower. So we actually, as per this pump curve, a 5 horsepower pump is what it's asking, but we know that we don't need that. In that case, we'll be overworking the pump, because the efficiency range for this pump is right in this shaded area. If we're outside of that area, which there's a chance you will be, and you'll still use the pump, if we're outside of that area, then it's no good. If you have a pump that's pumping that's oversized, you'll probably burn it out, or you won't be using it to its full capacity. Sorry about that. If you have a pump that's undersized, then you'll be burning it out. So once again, let me say that again. If you have a pump that is oversized, then you're going to be underutilizing it. It's like using a Ferrari for what a Volkswagen could do, and vice versa. If it's undersized, you're using a Volkswagen for what a Ferrari should be doing, if that makes sense. So that's how the pump curves, you read them. So you want to be in this efficiency range, but I have size pumps, especially whenever the pump is very, very deep, that you're outside of the efficiency. One pump in particular, we sized it and it was 45% efficiency, which is outside of the range, but we had to go with it. So if you ever have questions on it, just let me know. But my recommendation is, after you got the horsepower and you have the total dynamic head and the GPM, call the manufacturer. There's a windmill windmill pumps, Williams Windmill, and then there's another pump company, I can't think of it right now, TP Pump in Albuquerque. If you give them those 3 values, they'll be able to give you the pump you need. But if you want to figure it out on your own, now you know how to do it. The next thing we're going to go over is the gravity portion of the system. But before we do that, I forgot. So the pump has to overcome your lift, 100 feet, the 100 feet from the ground to the drawdown, friction and miscellaneous losses. So this value of this between the static line and the hydraulic grade line is going to be the friction loss plus the miscellaneous losses. So that's 1.7 feet. So that's going to be 1.7 feet. And then the elevation difference, you already know that's going to be 100. So you're going to pump to the static water, which is always the top of the tank, and then you have to overcome additional friction and miscellaneous losses, which we calculated to be 1.7 and 36.4. So I got that wrong. 1.7 and 36.4. 7, 8, 9, 10, 11, 6, 7, 8. So 38.1. 38.1 feet. So that's how much higher the hydraulic grade line is going to be above the static, and this is going to be 5 GPM HGL at 5 GPM, and that'll go all the way to the top. So next we're going to go do the gravity line.